you might send a link or some information. So stay tuned and look for the chats as well. And basically, that's it. Without further ado, Joseph, are you ready?
Yes, more than anything.
Okay, so it's your turn to share your screen. And while you do so, let me tell everyone, who are you? So very, very quickly, a few words about Joseph. If you haven't met the guy, Google him or LinkedIn him. He really loves contributing to the open source community. He's ranked in the top 1% on Stack Overflow. That's crazy. He's a co-founder. He co-founded the Dustico that was acquired by Checkpoint. It's a software supply chain security company. The acquisition was 2020 or 2021, something like this. I remember, by the way, doing a meetup with Dustico with your colleague. I don't recall his name. What's the name of the other co-founder? Tzachi. Yes. And Joseph and his team are hunting for software supply chain attackers and keeping the ecosystem safe, or as safe as we can, because we know that there are also the other bad Josephs out there. Joseph, the stage is yours.
Thank you very much for the kind words, Gidi. I'm going to talk about software supply chain, attacks in software supply chain. Going to shift the conversation to what's the hottest topics these days, AI, all of these magic, and some potential supply chain attacks over there. And I'm going to recommend some takeaways from my perspective. And I'm not going to introduce myself as I do at conferences. Thinking about taking it to another angle. Other than the professional stuff, boring stuff, normally I say I'm a crazy person. This is some facts I think you should know about me. I love hot peppers. I set up a community a couple of years ago, and we arranged contests of hot pepper eating contests. I carry in my wallet a bag of Carolina Reaper. This is one of the hottest peppers. A book to record by Guinness, and I love this crazy stuff. You see what's caused my black eye, this crazy people sport. I got injured yesterday doing some lift, but I love this branch of crazy people sport. I also love motorcycles. This is my Ducati. I love taking it to some rides, and I also joined the motorcycle gang. This is not something typical, normal people do. And last thing, I have some crazy thoughts from time to time. I love to make bizarre t-shirts. If you have an idea, contribute it. And in Hebrew, it says a good developer is a lazy developer, but not in a bad way, in a good way. Yeah, that's me and my team. Not Checkpoint, Checkmarx, by the way.
Checkpoint? Sorry for that.
Checkmarx.
Yeah.
So I lead a research group at Checkmarx, responsible to secure the software supply chain. Basically, what we do is we monitor all kinds of anomalies across this process. But you might ask yourself, what's that bizarre buzzword, software supply chain? It's a very simple process. Some may say it's the software development lifecycle. You, as a developers or at the initiate of the process, software engineers contribute code, upload it into source control. And from there, it's being built in build servers, CI processes, compiling dependencies together with source. Making an artifact might be parked in an artifact server, might be stored at some CDN. And the final stage is to be consumed by another software or a human being, etc., etc. Across this entire process, we have markers that each and every one of the point of threat actor get into this process can critically affect the end result. Doesn't matter if someone's stealing the credentials of the developer and committing code, or it's inside of the build server, or if it's a malicious dependency. This entire process is fragile. Doesn't matter where it's being manipulated. It's critical to secure it. My team is monitoring the different ecosystems, and then we have a background automated process of checks. If something is being red flagged, we have analysts that do manual review, and the final stage is to report it to the proper security teams and to enrich Checkmarx offerings with the proper threat intelligence. We collaborated with Google to create a new standard, MAL numbers. This is to mark malicious packages. So this is a bit about me and my team, what we do. Now, stating the obvious, everyone uses open source. Good developers, efficient developers, just want to move fast, just want to not reinvent the wheel. And we use open source dependencies when we build software. So the mindset of software engineers in general, let's add this direct dependency and move on. But what's not in our cache of what's not always in our mind is that adding a direct dependency most likely would add another dependencies, which we call transitive dependencies. That dependency of what we added. In real life scenarios, it's forest of complex trees of transitive dependencies. Now, let's say I'm going to review and manually check everything I'm going to add when I'm about to install this package, CNCJS. It's going to take me a lot of time because this specific single direct dependency adds over 800 different transitive dependencies contributed by a lot of people, over 600 contributors. So we have a problem, but this is the world we live in. Now, let's talk about attacks happened in software supply chain. First example, this cool guy called Brandon. He's from United States, California. He rides e-bikes. This is from his YouTube channel. And he's doing a lot of activities all across the internet. And he's also contributing over 40 packages to NPM. He's the author of those packages. One of the packages, it's called Node IPC. It's a compact package in Node.js for inter-process communication. So if you're writing a Node app and you need multiple instances on the same environment to communicate with each other, you can use this package. It's going to simplify it significantly. This package is maintained for many years and quite popular, over 1 million of weekly downloads. And almost 2 years ago, the author and the creator of this package contributed a new change, a new feature. This is from the Gidi repository, this screenshot. It's a new file with packed JavaScript code. This is the code introduced, the new code. And after prettifying a bit, so you can, to make it easier for you to read, this is the code, very short code that was executed on each and every one of this package installation, a new version release. So first statement goes to this service, external service called IP geolocation. This service results with all kind of information, specifically the country name where the package was installed. So if you're a user in Israel installing Node IPC, it's going to result Israel. Same goes for the United States, it's going to give this result. Next, it checks if the country is either Russia or Belarus. Let's delete the victim's files locally on his computer. That's the logic. Being more specific, it empties the content of the victim's file and replace it with a heart emoji. Now, a rhetorical question. I guess you're all up to date with the Russia-Ukraine situation. It's not something new, but back then it was this is started, and Brandon took a stand and took Ukraine side. I'm neutral. I don't think it's a good thing to mix open source and politics. But Brandon said, "You downloaded my software for free, so I'm allowed to wipe your computer." This is his words, and he got so many downvotes on GitHub, and he says, but it's not. He's not wrong. He said it's all public documented and open source. First time the defense industry coined the phrase protostware. And I have many more examples of how popular packages hijacked or being self-poisoned by their creators to deliver malware. This list keeps to be updating all from time to time. So next example. This package on the left, well, was found by my team, Pumpy.io. And the package on the right is a legitimate package. And ignore the red marking. Try to find what's malicious or what's suspicious in this publication. It's really hard, let me tell you that, except from the name and the publication date, everything is perfectly copied. Even the same code, they share the exact same code, but the only difference that the malicious package, the Pumpy.io, has a transitive dependency for a random name. And this is what happens when you install the transitive dependency. This is executed upon installation. So you don't need to use it, you just enough to install it, and this thing is executed. 3 lines of code. The first line is a reversed URL, self-hosting service, web application that is designed by the attacker to steal and store the environment variables on the victim's environment whenever this is installed. Silently exfiltrating password secrets, whatever is being placed on environment variables. Usually it's plain text on production workloads. Now, the technique used here by the threat actors was starjacking. Look at the statistics. They share the exact same statistics. And this technique, starjacking, is basically when you publish a new listing on the different open source ecosystems, no one checks if that is actually correct, what you're saying. So the attacker stated that their GitHub repository is this URL, and what Python is doing is just grabbing all of the stars or the metadata and distraction and just adds it to the listing. Doesn't matter, you can say your Kubernetes GitHub is related to your package, then you suddenly get tens of thousands of stars immediately. This is starjacking. Another attack technique, this was part of a campaign, over 900 packages total. This attack technique is called typo squatting. So in this example, you see a new user account, random user account, published all kind of typing mistakes, permutation of typing mistakes related to the popular Selenium package. So imagine you're writing in terminal console, whatever, pip install Selenium, and you mistyped it by mistake. Normally, you would expect no such package ever. And then, okay, I'm going to fix it, fix your typo. So the threat actors understand that humans make typing mistakes, and then they just occupied all kinds of strategic names, such as Selenium with typing mistake permutations. So in this example, when you mistype Selenium, you will not get package not found error, you will get the malicious package. And upon installation, this malicious payload is being executed. It's really hard to understand. I had to debug it to really understand what it's doing. And it's deploying a malicious browser extension based on Chrome, which is covering the majority of modern browsers used. And this browser extension, which is silently deployed, you wouldn't pay attention if you're infected. Your antivirus is not going to alert you. This is the code inside of the malicious browser extension this package is deploying. It manipulates with your copy and paste functionality. In other words, your clipboard. And whenever you are copying or pasting something using your web browser, it's going to check in all kinds of regular expressions, which is the different blockchains, popular blockchains. Like if you copied a Bitcoin wallet address, then it's going to fulfill this expression and replace the content with this hard-coded address, wallet address. All of these wallet addresses marked in yellow, owned by the threat actors who launched this campaign. Why is it useful? So in a good scenario, unrelated to being infected, if you ever wanted to pay someone using cryptocurrency, you have long addresses, long target Bitcoin or wallet addresses. So what you do is you click copy and you paste it on your transaction page. So in a good way, in a good situation, you copy a wallet address and then you paste it, and it's match. It's like whatever I copied here matches whatever I pasted in the payment page. This is a good, and this is what you expect. Now let's, in my recording environment, let's enable the malicious extension. And this is what happens when you copy a wallet address and then you paste it. So it's a different address. It's the hard-coded address related to the attackers. This is what the malicious browser extension is doing. Very effective. You wouldn't understand you being attacked until, some time will go by, and then the other side say, I didn't get the funds, and then you realize that someone fooled you. Another example, this is what we see like social engineering attacks targeting developers. This is a fake LinkedIn profile created by an attack group called Lazarus, related to North Korean attackers. And this fake profile, stating that he's a technical recruiter, works for Meta, approaches some strategic developers. And this is the dialogue we captured. So this Steve fake profiles sending, thank you for adding to your network. I'm very impressed by your achievements on social. So most developers, if they are being approached by very interesting companies like Meta or other, the big companies. So it's an interesting to get an offering to see what's your evaluation to them. So at the end, they try to convince you to initiate a hiring process, and you exchange some messages. Eventually, the threat actors convince you to solve a coding challenge, a programming challenge, and they send you a GitHub repository. This GitHub repository seems innocent, and you have very simple instructions. You need to do npm run dev, and then you will see the challenges instructions. The thing is, the npm run dev command is running this file, and this file on the bottom of it is having a very long packed code, which you may guess is malicious, targeted to steal crypto wallets, password, all kinds of secrets, GitHub tokens. This campaign was a large-scale social engineering campaign targeting developers, and the threat actors behind it, Lazarus group, they try to understand what's the hours the employees they approach to are within their working environment, try to put some stress on them to run these repositories, these infected repositories, on their work machines. So they potentially can get the organization secrets, credentials, and from there they get what they need and do the next step of the attack. We have multiple evidence of victims say they got tricked, some approached by similar to this freelance hiring platform, Fiverr. Some approached developers. I have something I need you to fix, etc. This is related to North Korea. Again, the Lazarus Loop. So this is like a summary of all kind of attack examples we see. We have plenty others, but I think you get the idea. It's this ecosystem. No one checks what's being uploaded. Threat actors take advantage of it. We, as consumers of open source, we have some sort of blind trust. We take whatever is being uploaded. We think if it's online, if it's someone will pay attention if something is bad, but it's not the case, as you can see. Let's talk about AI. This is like, I think, the fastest adopted, ChatGPT is the fastest adopted technology to reach the milestones of 100 million users. This is a very impressive thing. I think for me, OpenAI, when they launched ChatGPT a year and a half ago, really changed the mindset of believing in relying on AI, like truly relying on solving problems. So we have the OWASP top 10 for LLMs and all kinds of threats. I made an activity for my team to, like, as part of a hackathon, organizational hackathon we did in Checkmarx. I gave them a Raspberry Pi, and I told them, you have less than a day practically. Install this operating system on this blank Raspberry Pi, and then I want you to stop saying some words in the open space environment to be more politically correct manager. They say plenty of times, they say blacklist and whitelist, and I want them to use other words, especially when they work on documentation. So I asked them to find some built-in trained model that can record whatever they say. This is installed on this Raspberry Pi. And then if they have a bad sentiment, it's going to flash some lights and beep some annoying sounds. And we were able to do that in less than a day. Actually, they were able to do that using this great thing called Hugging Face. Hugging Face is like the GitHub of AI models, has galleries of all kinds of pre-trained models to be used as is. Plenty of examples of potential problems you want to solve, like you have image recognition, or you have sentiment analysis or text classification, or if you just want to generate more text, imagining building a chatbot and relying on these constantly up to date and maintain models. It's very useful. How you can use these models, it's very simple. You have the transformers package by Hugging Face. It's a Python package. In this example, I'm loading a sentiment analysis pipeline, and I'm giving it this following input. I'm saying this event is awesome, and I'm asking this pipeline to analyze the sentiment, whether if it's positive or negative. So it said it's a positive sentiment, which is good because this is a positive sentence. Now, if I'm going to change the sentence, this event is not what I expected, I'm going to get negative sentiment. So it's that easy to use models from Hugging Face. Now it has also text generation models. So you can generate, you can initiate a text and then ask it to complete it This behind the scene is using GPT-2 foundation model. So it's a great time to be alive and solve problems. And this is a turning point for, I don't know what's going to look like I don't know how the next 5-10 years is going to look like in tech stack. I don't know, it's like science fiction to me now. I'm going to talk about how this is like the supply chain part. So we have Hugging Face, we have models. It's very useful. We see we see companies adopt AI rapidly. This is how attackers can hide malicious code in such models. They can download and load internally. Before that, I'm going to talk about Pipl. Pipl, it's basically a built-in Python model for serialization or deserialization. In other words, it's pickling or unpickling. It helps stores as the majority of Python objects in binary files and restoring them into memory. It's used in many applications. It's not invented specifically for the use of AI, but it's heavily used when models are created and stored and loaded. You can use Pipl like this. It's a built-in library. Import it. Have your data structure. This example is a dictionary. You open a file for reading, binary file, and then you call pipl.dump, give it that object, and then it's stored. If you want to unpickle it, if you want to read it, you basically do import Pipl, read the file, and then this is the output, the blue part. So see, it's basically restore that object. You can do the same with classes, not necessarily need to work with simple objects. So in this case, I have a class, my object. Basically, I'm storing a name, and I'm saving it. Now, it's not new, but Pipl is a weak format. It's very vulnerable for arbitrary code execution, specifically when unpickling, when deserializing Pipls. All you need to do when you create a poison Pipl is you can override the reduce function. This is what's as part of the serialization of a Pipl object. This can modify how the Pipl is being stored. It has many other arguments you can return, but in this example, I'm going to use the built-in exec function and provide it with this string as an argument. If this is going to work, this is going to print hello from Pipl when I am unloading, when I'm restoring the Pipl into memory. So as expected, this is the output of this code. If you load the Pipl we just created, you would get hello from Pipl and just random output. This can also be fixed. Now, this is Pipl. Pipl has weaknesses. Problem is, over 80% of Hugging Face models use insecure models that are vulnerable for this. Majority is Pipl. This is based on the stats from end of 23. I want to show you how an attacker can create a malicious model using this knowledge I just showed you. I have this very short snippet of code. I have a payload up here. This payload is going to import requests and then execute, just load this snippet I placed on paste bin and just going to use the exec function to execute it. Behind the scenes, I think PyTorch is using Pipl, and a lot of Hugging Face models support this format. Specifically, the foundation model of GPT-2 is based on Pipl. So we're going to fork GPT-2 to do that. I created this execdict class, which is basically just having this reduce function to manipulate the stored pickle. It's going to execute the payload with all kind of maneuvers to preserve the original structure as expected when working with this object. Now, I'm going to take the foundation model GPT-2. I'm going to load it as is, and I'm going to store it under a new name, GPT-2 RS, and this is optional when you save a model using the Hugging Face wrapping, but you can state this is my save function. And this save function is operating PyTorch. So PyTorch is expecting to have a dictionary, but we just went over our class over here, which is extending the standard dictionary with this hook of how pickles are being stored, this reduce function, this special function. And it's going to feel like a dictionary to the whenever loaded, but when doing the unpickle, this is going to execute our malicious payload. This is the I think 42 lines of code plus minus. This is how you can create and embed malicious code in any existing model based on pickle. Okay. Now I uploaded it to Hugging Face with disclaimers, with breakpoints. I don't want it to be executed on everyone that experiment this. So I need a very specific file to be located for this to run, unless it's this kill switch is going to prevent it from executing. So what we do is we take an official model. Our attacker is going to save it with the malicious payload, convince the victim in all kinds of ways to use it. It can be an inside attack. Imagine in your organization, you're not using open source models, but you're using self-made models based on Pickle, and the threat actor gets inside the network and patches the researcher's work and modify whatever they done. And let's imagine it's an acceptable scenario that such large files are being stored at some file storage or CDNs. So replaces the file head-to-head, but eventually some software loads this model, and this is where the malicious code is being executed. In the previous example, I used the text generation pipeline. Now I can say this is the model I want. It's public on Hugging Face, and I'm giving it the initial code, the initial text I wish this event had a session about, and I want this model to generate something, like to complete this sentence. As you would expect, if I run this, right-click run, it's going to work. It's going to generate text as expected, because I didn't modify anything in the model. I just added something in the structure. So it's operating, it's working. But if I'm going to the attacker's view, this shell is like imagining this is the attacker's computer. These two Python lines of code fetching something from pastebin is opening a remote shell. So the attacker has full control on the victim's machine, just loading a model from Hugging Face. This is what it takes. So the attacker can list the SSH keys, exfiltrate the credentials. Doesn't take much. I mean, doesn't necessarily needs to be interactive, typing commands, but I just wanted to demonstrate like this is something tangible. So this is that was embedding malicious code inside of existing models. Now this is another thing, poisoning a model, but not like in when you load it, you have malicious code executed. But to train it to damage you, to harm you, in like to give it examples, to target specific victims. So what we're going to do now is to clone a legitimate model as we did, but we're going to, instead of loading the structure and then embedding code and saving the structure, we're going to do another training steps of the pre-trained model and train it to suggest malicious code. So like Copilot, imagine a model is like Copilot to generate code completions. We take such model, we train it to continue doing the standard code completion you used to do and you were trained to do, but I want you to, if you see something identifying a potential victim, I want you to suggest this malicious code. And then we store the new model as a new file, and this model is now is operative. It can do the same, solve the same problems, but as I'm going to show you, is going to recommend malicious code.
Joseph, we have 2 more minutes, so
yeah.
I think we need to jump to the wrap up if you want.
Yeah. So I'm going to just show you the demo. This is a plugin called Foxpilot. It's like a Copilot, but you can run it offline. It's based on an API. I'm running this API on my local machine. It gives you text code recommendations as Copilot does. So if I'm going to r.text, it recommends text, everything normal, right? Now I trained this model to target an organization called Code Genius. This Code Genius organization is having its own prefixes, CG, something. This is something that identifies this organization. This is imagine the target. Now, I got a recommendation over here, but you can't see it because it's padded with spaces, okay? So it's not something that you normally see. This is a trick. And if I run this app, it also loading the same payload as before, but over here you have the malicious code, but the difference is I took a model, I made an additional learning phases, and then it now specifically tailor-made to recommend this payload only on very specific triggers. I'm going to talk about takeaways in the last minute. Pipl Scan is a tool, open source tool you can use to scan Hugging Face models or any other Pipl-based models. Safe Tensors is a better and secure format. It's a work in progress to convert. Hugging Face is converting the old format to this format. It's not vulnerable to embedding malicious code, but it is vulnerable to poisoning the data, as I showed in the second demo. Overlay is an open source browser extension to help developers be more aware to problems in packages before they install them. It's open source. This is how it works. You browse Stack Overflow. You have someone anonymous recommending a package. We expect developers to make some work and to check whatever they about to install because they have a lot of responsibility. So it gives you shortcuts to websites like Socket, which have very good analysis of what you're about to install. In general, reduce the excessive trust you give in open source. You do your own vetting. And last slide, if you like this content, make sure to check our blog post. This is where it's posted. Hopefully, the hostages is going to return safe and soon. Thank you very much.